Hey mathematicians, I'm Amy and I'm ready to teach you some common sense calculus. Today I'd like to look at the unit circle and talk to you about how to navigate your way around the unit circle in terms of radians. Most of us are pretty familiar with degree measure in angles and circles. For instance, you probably know that all the way around a circle is considered 360 degrees. And that halfway around a circle, that angle measure, the flat angle there, is 180 degrees. So what about radians? Well, we know from geometry that the circumference of a circle is equal to 2 times pi times r, which is the radius. No matter how big or how small the circle is, I know that all the way around the circle is 2 pi radius. What does that mean? It means that I have a distance, that arc length all the way around, is equal to 2 times the number pi radiuses. So a little bit more than 6 of these radiuses get me all the way around the circle. I said a little bit more than 6 because pi is a little bit more than 3. So 2 times pi is a little bit more than 6. So then when we think about radian measure, we're measuring the angles, and that radian measure is going to match up to how many radiuses it takes to create the arc length that we're measuring. So for instance, back to 360 again. If this is the terminal side of the angle right here, and then we're opening that angle up all the way around 360, as we know, that's 2 pi radiuses all the way around. So we're going to consider that angle 2 pi radians. And of course, 180 degrees, half of that, only takes pi radians, or about 3.14 radiuses to create that length. So that angle is going to be considered pi radians. So those two are pretty straightforward. So let's talk about other radian measures around the unit circle. So half of 180, of course, is 90. So that's clear that that one would be pi over 2. Those are kind of the easier ones. Start here at 0. I have pi over 2, 2 pi over 2, which reduces to 1 pi. And then I go another tick over here. This is going to be 3 pi over 2. And then all the way back around the circle, we're at 4 pi over 2, which reduces to 2 pi. So again, if you think about going around kind of quarter circles as we go, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So I use a similar method for that to come up with the other radian measures. Let's start with all of the multiples of pi over 4. So you'll notice I've taken the unit circle and I've shaded in every other piece here, every other wedge, and you'll notice at the top half of the circle I have 4 equal wedges. So I took my 180 degrees, or my pi radians, and I cut that into 4 equal pieces. So 1/4 of that would be 45 degrees, or 1/4 of pi is pi over 4. So I know that each of these wedges has an individual angle measure of pi over 4 radians all the way around the circle. So this first one, of course, measuring from 0 to here, is pi over 4 radians. If I go another pi over 4 radians, so that's 1 pi over 4, I can consider this guy 2 pi over 4, which of course we already talked about it being equivalent to pi over 2. One more tick over here and we're at 3 pi over 4, and over here 4 pi over 4, which of course is 1 pi. And you can just keep going around the circle. I've got 5 pi over 4, 6 pi over 4, which is 3 pi over 2. Of course, here is 7 pi over 4, and we finish full circle with 8 pi over 4, which is equivalent to 2 pi. Normally, we're going to look at each of the radian measures in its most reduced form, but if you're going around the circle and counting out in terms of pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, etc., 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 just know that you can reduce them to get kind of the standard name of that particular angle. Next up, let's look at multiples of 60 degrees, or pi over 3. You'll notice that I've taken the unit circle now and I've cut it into 1, 2, 3, 4, 5, 6 wedges. Each wedge has an internal angle of 60 degrees, or pi over 3. So if I go around the circle, once again, here's my initial angle, and I'm going to open up to 60 degrees, or pi over 3 radians. We can keep going, and now this angle here is 120 degrees, or 2 pi over 3 radians, etc., etc. So I'm going to go around the circle. I've got pi over 3 radians, 2 pi over 3 radians, 3 pi over 3 radians, which of course is just 1 pi. Here is 4 pi over 3, 5 pi over 3, and finally 6 pi over 3 radians, which reduces to 2 pi. Now, of course, we could keep going. Going around once plus a little would be 7 pi over 3, 8 pi over 3, 9 pi over 3, etc., etc. We also could start here at 0 and go backwards, where this guy here would be negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, or negative pi, and so on. Finally, let's look at multiples of 30 degrees, or pi over 6. You'll notice that now I have every other wedge shaded, and each wedge has an angle that's equivalent to 30 degrees, or pi over 6. So again, I took my 180 degrees on the top and cut it into 6 pieces. So this guy here is pi over 6. And just like we did with the pi over 4s and the pi over 3s, we're just going to go all the way around the circle to identify each of the angles. So again, starting here, we had 1 pi over 6. There's 2 pi over 6, 3 pi over 6, there's the angle, 4 pi over 6, etc. So let's go ahead and fill those in. Again, that was 1 pi over 6, 2 pi over 6, and of course that reduces. We already knew that this angle was pi over 3. Here is 3 pi over 6, which we know is pi over 2. 4 pi over 6, which reduces to 2 pi over 3. So that makes this guy 5 pi over 6, 6 pi over 6, which equals 1 pi, 7 pi over 6, 8 pi over 6 is 4 pi over 3, 9 pi over 6, which of course is 3 pi over 2, 10 pi over 6, 11 pi over 6, and finally our 12 pi over 6, which is 2 pi. The next thing you should do is print out a blank copy of the unit circle from my website and practice. Do it as many times as you need to feel confident. Make sure that you can fill in all of the multiples of pi over 6, pi over 4, and pi over 3 all the way around the circle. These are really the only angle measures you'll need to have memorized for calculus, and with enough practice, it'll just seem like common sense. In our next video, I want to talk to you about how to identify the coordinates for each of these key angles on the unit circle, and how to use those to find out the various trig ratios around the circle, such as cosine and sine, and all the rest.